Hi everyone, today we're going to take a look at ellipses. Okay, so an ellipse is basically an elongated circle. So it's been vertically expanded or compressed, or horizontally expanded or compressed. And when thinking about everything we've learned in transformations, it makes sense that after you've learned something to do with circles, you would learn something to do with ellipses. So think of a stretched circle and think about what that might start to look like. And the ends of the circles, you can join them together, and it would no longer be called a radius because they wouldn't be equal vertically as they would be horizontally. But the longest chord in the ellipse, so whatever is the longer part of the ellipse, is called the major axis. And the shorter chord is going to be called the minor axis. And the major axis and minor axis intersect at the center of the ellipse, and the endpoints of the major axis are called the vertices of the ellipse. Okay, so think back to transformations and think of how we could start to create some ellipses. So here's a basic circle with a center 0, 0 and a radius of 1. So compared to that specific circle, what would happen for part A right here? And when you look at something like that, you would have to say, well, x has been replaced with 1/3 of an x, or x over 3. And when that happened back in chapter 1, we would say that would be some sort of horizontal expansion, and it would be a horizontal expansion by a factor of 3. So we can fill that in right here. And when y gets replaced directly, and y is getting replaced directly here with 1/5 of a y, then that would represent a vertical expansion by a factor of 5. And of course that would only remain true if that's a 1, just like we had a 1 right here, but that's going to be the case for the definition of how we express our ellipses. So based off of that should make a lot of sense. Now, a form that's going to look a little bit more common would be something like part B. And so for part B, let's take a look at the translation first. And so x has been replaced with x minus 3. So we're going to say that we're going to move 3 units to the right from 0, 0, and we're going to move 2 units down. And another way of saying that is our center is going to be the point 3, negative 2. And this 16 and this 36, they're perfect squares because you could have written it as saying x minus 3 over 4 all squared, but generally we separate the numerator from the denominator, so we just have to understand that this is like saying 4 squared, just like that 36 is like saying 6 squared. And the 4 would act similar to how the 3 acted right here, and that would represent a horizontal expansion by a factor of 4. And it would represent a vertical expansion by a factor of 6. And if you're saying a vertical expansion by a factor of 6 compared to what, we'd be comparing this, in this case, to our basic circle with a radius of 1. So now we have an example where we see an ellipse, and let's first start just saying, well, what are some of the characteristics of this? And we have a center point right here at -1, -2, -3, at -3, -5. And the length of the minor axis would be 4 units, and the length of the major axis would be 1, 2, 3, 4, 5, 6, 7, 8 would be 8 units. And now they want us to come up with an equation for this. And so if you think about what we saw in example B from the previous question, we could say this would be something to do with x plus 3 squared plus y plus 5 squared equals 1. And horizontally, we've gone 2 to the left and 2 to the right, and 2 squared would give us a 4. So that would represent something that would look like it's a horizontal expansion by a factor of 2. And if you're still not sure how we came up with that 4, it's because it's 2 squared. And that's because from the center, we've gone over 2 units, and we've gone up and down 4 units each. So then we're going to put here a 4 squared or a 16 like that. So we'll say 4 squared. And then that would be something that would show our ellipse. And if you want to double check that, you can always look on Desmos, and you can graph that, and it should line up. Okay, so we're going to start joining a lot of the things that we've done from the previous few classes. So this is starting to look a little bit messy here. They're saying graph this ellipse. This is in general form, and we wouldn't even know where to start because it doesn't give us the characteristics of what we need to be able to graph it. And so if we want to graph this, we need to rearrange a whole bunch of things. I'm going to resort it so that our x's are next to each other and our y's are next to each other. So over here, let's say this. We could have 16x squared plus 96x plus 4y squared minus 8y plus 84 equals 0. And so from here, we can look to complete the square twice. So with our x's, we would factor out a 16. And we'd have x squared plus 6x blank blank. And then with the y's, you would say plus 4y squared minus 2y blank blank, close bracket, plus 84 equals 0. And we want to invite a couple values in, so we can invite in plus 9 minus 9, and we can invite in plus 1 minus 1. In each of these cases, we want to then kick out the back values. So this -9 that gets kicked out, you have to remember that it's being expanded by 16. And so 16 times -9 would give us -144. And then this 4 and -1, when I kick out this -1, it gets times by the 4, and that would be -4. And so now we can start to clean this up a little bit. And we could say we have 16x plus 3 squared plus 4 bracket y subtract 1 squared. And then over here we would get -60, -64. And so this -64 that we have all over here, I'm going to add that onto the other side. So we have plus 64 on the right side. And we know that if we want to write this, we probably want to keep our right side to be equaling to 1. So let's divide by 64, which means we divide this side by 64. And so that's going to act on this 16 and this 4 right here, each of these individuals. And so you would have something that would say x plus 3 squared over 4, that's 16 over 64 in lowest terms, plus y minus 1 squared over 16, that's 4 over 64 in lowest terms, equals 1. So from here, we would have a center of -3, +1. And let's plot that right here. So -3, +1. And our x's are going to go 2 left, 2 right, because that's 2 squared. And our y's are going to go up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. And that's because that would be plus or minus 4. We can join that together, and that would be our ellipse. Okay, so a lot of moving pieces here. Hopefully completing the square seems a little bit more comfortable now that you've done that for a couple lessons. Okay, moving on to example 3. Determine the length of the minor axis of an ellipse with vertices 5, 2, and negative 3, 2 that pass through the point 1, negative 1, and determine the length of the minor axis. I'm pretty sure we just asked that at the start of the question. Okay, so let's do a mini graph and let's see what we have right here. So we have the point 5, 2, and we have the point negative 3, 2. And if you know that those are the vertices, then if you average that out right here, so if you went 4 in each way, you would have the point 1, 2. And that is going to be the center of our ellipse. And we know that because the vertices are on part of the major axis, and if you average that out, that will give you your center. You could use the midpoint formula if you want to, but I don't think that's really necessary. And so from there, we also know we have the point 1, negative 1. And that's a point that's going to be on the ellipse, but it's actually a very important point because it's 3 directly down below from where the center was. And so if you know that, and you were to start to sketch what it would look like, then you could actually predict then that the minor axis would be 6 units, because you would go down 3, just like you would have to balance it to go up 3 to the point 1, 5, and that would be our minor axis right there. Okay, there's a lot of different types of questions that you can ask for ellipses. So this one here is saying, if you had something that was in graphing form, would you be able to have the tools now to write it in general form? And to do something like that, 16 times 25 is going to give us 400. And so what you could do there is you could times each numerator by 16 times 25. You could say 400 right away if you wanted to. But what you want to do is you want to find the lowest common denominator. And if you find the lowest common denominator, then you can get rid of the denominators and you'll be able to just have something that won't have a fraction at all. So these 16s would reduce with each other, and these 25s would reduce with each other. And so you'd be left with something that would say 25 x minus 1 squared plus 16y squared equals 400. Now you can't expand that 25 in there because that x minus 1 is being squared, but what you could do is you could write out the x minus 1 squared in expanded form. And so from there you would get 25x squared minus 50x plus 25 plus 16y squared equals 400. And now you can start to rearrange it and put it in the order that you want to be able to have it in. So you could say 25x squared plus 16y squared minus 50x. There are no y's, but you could subtract over the 400. And if you minus 400 and you join it with the 25 right there, you would get negative 375. And something like that would be your general form. Okay, example 5 is a challenging example, and it's probably something you're gonna hear me say in class. You know what? We could probably end up omitting that or something along those lines. I'm going to rewrite 2kx squared plus ky squared equals 1 in a bit of a different form. It says, this makes an ellipse with a major axis of 12 units. What would be the value of k to make something like that true? And so what we could potentially do is you could think of like, how could I rewrite this to maybe make things look a little bit easier. So this 2k here and this k here, I'm just going to rewrite, and I'm going to say it would be x squared over 1 over 2k. And that might not look easier, but that's an equivalent form of it, because if you were to times by the reciprocal, you would come up with the exact same as your original 2k x squared plus y squared over 1 over k equals 1. And what you want to do is you want to look at this 1 over 2k and this 1 over k, and you want to figure out, well, what's a bigger value? Is it 1 over 2k or 1 over k? And if you pick a number, say you pick a number 3 or something like that, and you put it in for k, no matter what, this 1 over k value is going to be bigger. 1/3 is bigger than 1 over 6, 2 times 3. But whatever number you put in for k, you're going to get something with what we're looking for here, in which that 1 over k is going to be bigger. And what do we want that 1 over k to be? Well, if we know it's bigger, then we know that's where the major axis lies. And the major axis is going to be, well, it means that it would be something in which you would be going up 6 units and down 6 units. And if you're to write that in a y squared form, you would be dividing by 36, because that would produce 6 squared, meaning you would go up 6 and down 6. And so then you could say that means that 1 over k must be equal to 36. And if you want to solve for k based off of that, you could times both sides by k, divide by 36, and k is going to equal 1 over 36. So it's a really abstract question. I'm sure that there's probably a couple questions that I should ask before we get to an example as weird as example 5 here. But that's what we come up with for a value of k to make this a true statement. Now, some of you are probably still recovering from the parabola lesson and figuring out what we learned with the directrix and the focus. And so here we have something in which we have the foci. And when looking at an ellipse, we have a foci. And it says the focal points of an ellipse are on the major axis and are equidistant from the center of the ellipse. Okay, so here's an example where here's the center of your ellipse, and if you go to the left, you go to the right, you're going to create these 2 focal points right here. And by definition, what we're going to say is this. We're going to say that this distance over here, okay, and this distance over here, if I take that distance, distance u, and I add distance v, then it's going to be equal to the major axis, which in this case is, we would say it's 2a units long. And that's the definition of it. And what we need to know is we can say that the foci can be found by using a squared equals b squared plus c squared. And we're going to use that all the time for our ellipses. Again, that's going to be a formula that you're going to be given for upcoming assessments. And there is quite a lengthy proof, I think on page 369, that you'd be able to look back in Michelson and be able to try to look at it in a little bit more detail. But for our sake, in terms of what we're looking at right now, we're going to say a squared is equal to b squared plus c squared. And just to be super clear on what we mean by that, because some of you are saying, wait a minute, is this Pythagoras? It's not Pythagoras. A squared is going to refer to something to do with our major axis, because our a values are our major axis. Our b values are going to refer to something with our minor axis. And our C value is what they're referring to here, and that's going to refer to the foci or the focus. Okay, so keep that in mind for some of our upcoming examples. Okay, so our next example says, find the equation of an ellipse with a center at the origin, a major axis of length 10 units on the x-axis, and a minor axis of 6 units. Let's start by sketching it out, and then let's see if based off of that we'd be able to find out what the two foci would be. This is actually a pretty straightforward question, but we're introducing this concept again of being able to find the foci. So we have the point 0, 0, and from here they're going to say that we're going to have a major axis of length 10 units, which means I would go 5 to the right and 5 to the left. And it also means that our minor axis, it's telling us, is 6 units, so you go up 3 and down 3. And based off of that, let's draw this in here. Okay, now the length of A is 5. Remember, the length of the total vertices would be 2A, and that would be 5 plus 5, which is 10. And our length of B is 3. And 2B would be 6 units, which is the length of our minor axis. And so what they're saying is, well, where do we need to place the foci to make this a true statement for our ellipse? Like where would this be? And so we're saying, well, if a squared is equal to b squared plus c squared by definition, we could say 5 squared is going to be equal to 3 squared plus c squared, and you'll probably recognize that this is one of our Pythagorean triplets. And so you could say 25 is equal to 9 plus c squared is equal to 16, which means that c is going to be equal to plus or minus 4 after you take its square root and create a plus or minus situation. And so what that means is, right here at the point 4, 0, and right here at the point -4, 0, you would have your foci points right there. And those would be the two of them. And if you want, you could try to see what that would look like if you wanted to draw out some triangles. But bottom line is that's a good example because it uses our 3, 4, 5 ratio in terms of trying to be able to show where to find foci points. Okay, a couple more examples. Find the equation of the ellipse with a center at the origin. So again, we get to use 0, 0 with a focus of 0, 3 root 2 and the minor axis of length 6 units. Okay, so we could do a mini sketch if we want, and that could potentially help us out. We have a center at 0, 0. At 0 root 3, 3 root 2, we would have something right here. I guess we know that we could balance that out with the other point for the foci. Whoops. Right here at 0, -3 root 2. And it's saying that the minor axis is going to be of something that would be of a length of 6 units. Okay, so let's think about what we know with this. If we say a squared equals b squared plus c squared, and our c value from 0 up to 0, 3 root 2 is a height of 3 root 2. And so that means that our c value would be equal to 3 root 2. And our minor axis is a length of 6 units, which means that if the minor axis is a length of 6 units, then you would be going 3 each way from the center. So it would be 3 squared, or b value is going to be a value of 3. And we can solve what a is going to be from that. So a squared is going to be equal to 9 plus, this would turn into 9 times 2, so 18. So a squared would be equal to 27. And we could square root it just to find out what a is, but we actually probably like the value of a squared, because from there then we could say that we have x squared over 9 plus y squared over 27 equals 1. And you might be saying, how did you know that the 27 was going to go with the y squared and the 9 was going to go with the x squared? Like, what, did you, how did you know that? And that's because if our focal points right here are, you know that they're always on the major axis. So we know that we would have something that would look like this. And so here, I probably could have said this earlier, we had the point 30, and we'd have the point negative 30 right there. And that would tell us that we're moving 3 to the right and 3 to the left from 0, 0. Okay, a couple more examples. Find the equation of the ellipse with a foci of 10, negative 2, and 4, negative 2, and an endpoint on the minor axis at 7, 0. So I don't know about you, but I find that doing these mini sketches really helps me to be able to see things a little bit better. So 10, negative 2 could be right here. 4, negative 2 could be right here. And let's average that out, and then that means that at 7, negative 2, that has to be our center. And it also tells us that we have an endpoint on the minor axis at 7, 0, right here. And so if that's going up 2 units, then we know that we would go up 2 units, but it also means that we would have to balance that by going down 2 units to find the length of our minor axis to be 4 units in total. So from here, let's start by putting in our center. We could say something like that. That would give us the coordinates of our center. 7, oh sorry, it was 7, my fault. It's the center is 7, negative 2. Okay, and then we know that our minor axis went up 2 and down 2, so it'd be 2 squared, so our value there would be 4. And we don't know what we would have down here right now. So in order to complete that, we need to use our formula. A squared equals b squared plus c squared. We know that our b value was 2 squared. And we know that, and we know that our c value, from our center, we went 3 to the left and 3 to the right, so we would say our c value is going to be 3. And then we could find out what the value of a squared is going to be. So a squared is going to be 4 plus 9, so a squared is going to be 13. And that would be, I'm just going to erase this here, that would be the equation of that ellipse. Okay, hopefully you're starting to find this a little bit repetitive, maybe a little bit easier than what the start of the lesson was. Okay, so I believe this is our last example. Then we have a couple practice questions, but I think this is our last example. Okay, so let's Let's do another mini graph. Okay, we have the focus point at -3, 8. And we would have a vertex at, up here, at -3, 10, as well as -3, 2. And so if we have something like that where those are the vertices, you could average that out, and 10 and 2 would average out to 6. So that means that you would have a center point right here of -3, 6. And based off of that, you could start to write your equation. You could say it would be x plus 3 squared plus y minus 6 squared equals 1. And then we got to figure out what would be on our denominators here and here. And so we know that if we're looking at our a squared equals b squared plus c squared, if our vertices right here, if our total major axis is 8 units, because we went 4 and 4 from our center point of -3, 6, then our major axis would be going 4 squared units, which would give us a 16 right here. And thinking about how that would look then if we wanted to plug some values in here to be able to see what we could get, we could say this would be 4 squared, and that's our major axis. And it's going to be equal to, well, we don't know what our minor axis is, but we do know something about our focal point, because if we had a focus at -3, 8, that's a distance of 2 units above from the center. So then it would be plus 2 squared. So that would give us 16 equals b squared plus 4, which means b squared will equal 12, which means we could put a 12 right here. So the focus is quite repetitive for ellipses. We got a couple practice questions right here. I'll just talk you through them a little bit before we go through some of the homework. But basically, we'll because we had so many examples there, I'm not going to go through these right now. But this would be an example of completing the square for part A and for part B. And for part C. So you get lots of practice on that. We've done that a little bit recently, so if we want to do that in class, we can use that as a warm-up. And then for example 4, this would be coming up to try to create something. Let's look at example 4 and let's look at example 5 here for extra practice. So if you have a center of -1, 2, I would say every single one of those has a center of -1, 2. The horizontal major axis, so connected to your x, is of length 8. So if you take your 4 to the right and 4 to the left to create your major axis, then that means that 4 squared would give you a value of 16 as a denominator. Okay, and so that is shows up in D and it shows up in A. And then it says a minor length of 4 in total. So that means you would go up 2 and down 2, and 2 squared would give you 4. So this would have to be D. And then finally for the last question right here, what's the length of the major axis of the ellipse? This is an easier question. So right here, this would be 4 squared, meaning that you would go up 4, down 4. And if you go up 4 and down 4, that would give you a total of 8 units. So I may be cutting down the homework. I should probably take a look at this right now just to before you guys get started. Let's well, you know what? The questions are reasonable. I would say let's change one thing here. We'll just say for question number 2, you can worry just about A and C instead of doing all of them for that, and I'll cut down a little bit in terms of what you need to be able to do. So, okay. Hopefully that was good, and that's ellipses.